All right. This is Mr. Holsey with H Squared Sufficiently Understood Science, and we are going to be taking a look at metals, nonmetals, and metalloids. This is continuing our discussion on the periodic table. So, elements are going to be classified into three groups in the periodic table. These are going to be the metals, which constitute the majority of the periodic table, metalloids, which are only a small part, but you can see those right there. They make a little zigzag pattern. And then the nonmetals, which includes hydrogen, which is over here actually on the metal side. So essentially, as you move across left to right across the periodic table, the elements become less and less metallic. So if you start off in group 1, they're extremely metallic, and as you move over all the way to the right side to the noble gases, you've made it to the nonmetals. So elements at the left end of the period, such as titanium, are extremely metallic, whereas when you get closer to the middle or farther right, the metals like germanium, they are less metallic, and elements on the very far right, the end of the period, such as bromine, are non-metallic because they are non-metals. Now, even though these metals are moving from more metallic to less metallic as you go across the periods, the groups themselves do have similar physical and chemical properties. Okay, so if we're looking at the periodic table of elements, you can get a sense that they have similar characteristics, almost like family. We call them families for a very specific reason, because think about your family. You have similar characteristics to your parents, either personality-wise or as in looks. One of my favorite examples, and I'm going to use this again later here, is this group right here, group number 1, the alkali metals. They're all silvery, soft, shiny, very, very reactive metals. And so you have lithium, sodium, potassium, rubidium, cesium, and francium. They're very, very, very reactive. If you throw these things in water, they make a big boom, and it's really, really cool. And so they have very similar chemical characteristics. Now, as far as physical properties, I always like to look at group 1B or group 11. Okay, that's this group right there. I'm going to redo that right now. Okay, this group right here. This is copper, silver, gold, and we have an idea what those look like. They're shiny. You can easily they're easily malleable and things like that. They have they have similar characteristics, both physical and chemical. So our noble gases, for example, are having similar characteristics. They're inert gases. They're non-reactive. And here we have that copper, silver, gold as well. And you can see how they are easily shaped and have very similar properties. Aside from their color, there's not much difference, as you can tell. They're both all shiny, have luster, and things like that. Speaking of luster, let's take a look at some of the terms we're going to be learning today. So luster is the ability of an object to reflect light. So objects that are metallic are going to reflect a lot of light, like gold, okay, silver. Non-metallic objects, like this chunk of sulfur right there, is non-lustrous. They are not going to reflect a lot of light. Conductivity, meaning they conduct electricity, and this is going to be mostly in the metals. The metals are going to conduct electricity. A lot of the wiring in your house, well, all the wiring in your house, but most of the wiring is going to be made of things like copper and things like that. And so we get some pretty cool stuff like this big old Tesla coil right there. You can see that thing's It's made of metals that are conducting large amounts of electricity. And we can test this with a conductivity meter. You can actually build one of these yourself with a fork, some wire, a little tiny light bulb, and that's all you really need. And so you can actually create your own conductivity meter. It's actually pretty fun. Malleability means it can be hammered into sheets without breaking. So you can see some art right there where they've taken metal and hammered it out. And ductility means it can be pulled into a thin wire. So here we have an example of malleability where the blacksmith is heated up some stuff and was breaking and smashing it. Here we have ductility where it's pulling this piece of metal into a long wire. And so you can actually take a cube of silver that's like one inch by 1 inch and pull it into I think about 2,000 feet of wire. It's very ductile. Brittleness is if it breaks easily. Elements like sulfur, which is a non-metal, easily breaks in your hands. You can crumble it up. But other things, other metals, tend to be a little less brittle. They don't break as easily. Some do, some don't. Also depends on how you heat them up. But right here you can see an example where an iron file has broken. This is a brittle fracture, but for the most part, metals don't break near as easily. They're more malleable. Then we have the reaction to magnetism, where it reacts to the pull of geomagnetic forces. And actually, this is how we know that the Earth's magnetic poles have not always been in the same place that they are today. Because what we'll see in rock formations is that tiny magnetic rocks or minerals actually will align themselves to where the pole is at that time before they were solidified into their rock formations. And so what we'll see is if the pole, let's say we have the Earth here, and let's just say the North Pole is here, the South Pole is here, these magnetic little particles might be facing all in this direction. But later, as time goes on, let's say the North Pole and South Pole shift, and so we can tell that the North Pole, based on the geologic evidence, that the North and South Poles have shifted over time, which we are terribly overdue for a good pole shift. So let's talk about metals. Uh, the metals, you probably have a good idea of what they are, but let's go through their characteristics and properties. So metals are on the left of the zigzag on the table. So this green area right here are going to be your metals. So metals have some very specific characteristics. They're going to be solid at room temperature for the most part. One exception is mercury, which is a liquid at room temperature. And little piece of warning, don't ever handle mercury at all. You're going to get sick. It absorbs into your skin and you can get heavy metal poisoning. Don't handle mercury. Metals are good conductors of electricity and heat, but there are some that are better than others. For example, we talked about copper, silver, and gold. Copper is a great conductor of electricity and heat. However, gold's actually a better conductor of electricity and heat than copper is. And so some of them are better than others. You'll find a lot of like cooktops and everything like that. You are going to be using this. Some of them use ceramic now, but for the most part, they're using metal components to conduct that electricity and heat. Metals are lustrous, which means they have a shiny metallic appearance. Um, and metals are malleable. It can be hammered into sheets without breaking. So a lot of ancient art and even today, you'll see art made out of metals. So they're also ductile and can be drawn into wire. So 1 ounce of silver, I think I misspoke earlier, but 1 ounce of silver can be drawn into 8,000 feet of thin wire. That's 1 ounce, which is not that much. So ductility is the ability to be drawn onto a wire. Now, if you're having trouble imagining that, think of like guitar strings. And metals are sometimes magnetic. They're not always magnetic, but like for example, gold is non-magnetic, but it's still a metal. But a lot of metals will react to the magnetic poles. Now, on the other side of the spectrum, we have the nonmetals. So nonmetals are going to be on the right of the zigzag. So this orange area, okay, this orange area that I'm circling right now, as well as over here with the hydrogen. Some will argue, some will argue that hydrogen can either be placed here in group 1 or you could possibly transport it to be on top of group 17. There is good points on both ends because of the way the valence electrons are and the way that hydrogen acts. So nonmetals are solid, liquid, or gas at room temperature, and they are going to change form based on how much energy they have absorbed at that time. Now, a lot of you say, hold on, wait, don't you mean heat? Doesn't heat transfer and cause changes of state? Well, remember, heat is energy. So you need to make sure when we're talking about this, we're talking about a change because of an increase in energy. Now, nonmetals are bad or poor conductors of electricity and heat. They're not that great at it, but they do have some uses in manufacturing. Nonmetals are also not lustrous and are not shiny or metallic in appearance, so they are not a very strong. You don't see these in too many um, in jewelry or anything like that. Nonmetals tend to be very brittle when they are solid, so they break quite easily, and they are never magnetic. They are never magnetic. So let's take a look at metalloids. These are kind of like the best of both worlds in some cases. So metalloids are on the zigzag on the table. So these guys right here. It's kind of like the dividing line between the metals and the nonmetals. Metalloids are kind of a weird situation where they have a little bit from column A, a little bit. So the only exception on this along that zigzag is aluminum. It's considered to be a metal even though it lies along the zigzag. So metalloids basically have no set characteristics and share properties of both metals and nonmetals. They can be a little lustrous, They could be magnetic. It really depends on the individual element. So some examples here are they could be a good conductor, but be very brittle. They could be lustrous and brittle, magnetic and brittle, lustrous and magnetic, a good conductor and magnetic. It could go on and on, just different combinations of these. And that's going to wrap it up for this lesson on metals, nonmetals, and metalloids. Please remember to like, share, and subscribe, and hit that little bell notification to know whenever we put up a new video. So have a good day, and thanks for watching.